Hey there. So we will begin shortly in about 3 minutes, and till then I'll set up my coffee. So I bought some coffee. I could have made at my own place, but there's no fun in that. And a little bit of sugar has fallen out. Wow. Okay. Put packaging aside. Am I audible? Okay. I should probably get a. I should probably visit the barber soon. Okay. Take the lid off because I've never been able to use these lids. I'm always scared that it will fall out of the lid. Smells good. It actually smells really good. Vanilla flavored coffee. Let's put in some sugar. That's enough sugar. Let's mix it. There's a lot of foam. Mhm. What happens if I use a high preset? I think it will use more CPU. Okay, it's good enough for now. Um, did the timer restart? I think the timer restarted, right? Let's update the timer to be 1 minute, and we will begin. We will start in a minute, and let's taste the coffee. Actually good. It's not that hot as well. Till then, I will close all the tabs, unnecessary windows. Mm, okay, that's about all. All right, let's get started right away. Okay. Mm, we don't need this. We can pin this and By the way, about this timer, I can do refresh. I can remove it. Okay, can you see my terminal? I think you can. Let's go. Where were we? We were doing Rustlings. Uh, let's go with the dark theme. Mm, Rustlings. Okay. So we have done uh, 25 out of 94 exercises, and our next exercise should be move semantics. Move semantics 1. Okay, so what does the error say? At line number 5, let me set line numbers. We have a vec and we are trying to push into it, and then we want to return cannot borrow as mutable. Okay, we cannot mutate, as we learned yesterday or the last time. All the variables that start with are by default immutable unless you specify. So let's implement the suggestion that they are giving us, and let's save it. That fixes the problem. Let's look at the hint as well, because these exercises are move semantics is a very key concept for Rust. So let's look at the hint. So you have got the cannot borrow vec as mutable, as it is not declared as mutable. Error on the line where we push the element to the vector, right? The fix for this is going to be adding one more keyword, and addition is not on the line where we push. Try accessing vec0 after having called fill and see what happens. So we have called fill here, and if we access vec0 here, let's do vec0. Value used here after the move. So value has moved. Move occurs here. Occurs because vec has that vec value moved here. So they are saying that the vec0's value got moved, and I cannot access vec0 after here after the move. Oh. So this is where we are going to learn what moving is all about. Let's go to the next exercise. Move semantics 2. Move to why do I keep getting uh, anyways. What does the error say? Move occurs here because vec0 and value moved, and then the vec0 is being borrowed after the move. We're trying to access the vec0 after the move. This parameter takes ownership. This parameter takes ownership of the value. It owns the value inside of this function, and then we are never really returning back the ownership. This error originates in the macro. Consider cloning. We could instead of sending back the instead of giving them the original vec0, we can give them a clone of it. That's what the Clippy is suggesting here. But let's look at the hint. Running this exercise for the first time, you'll notice that an error about borrow mode. In Rust, when an argument is passed to a function, it is not explicitly returned. And it is not explicitly returned, you cannot use the original value anymore. Okay. This is something that needs to be noted. Note this. We will call this moving a variable. When we pass vec0 into fillback, it's being moved into vec1, meaning we cannot access vec0 anymore. Yeah, so basically they are also suggesting us to do the cloning here. Yeah. So let's do what they're telling us to do. We can let them teach us and not, okay. Yeah, so this is done. Now let's move on to move semantics 3. Move 3. Okay. Okay. Uh, all right. So here cannot borrow vec as mutable as it is not declared as mutable. Okay. Line number 2. So here they're declaring immutable variable. They're passing the immutable variable to fillback and then they're trying to mutate it. You see what's happening? Before we go on to hints, I think let's start with fixing it. Uh, Declaring a new variable, since this should fix it when you're done experimenting. And the difference between this one and the previous one is that the first line of fillback that had let me check, there is no longer there. You can, instead of adding that line back, existing binding to be immutable instead of an immutable one. But doesn't this mean that vec is vec? Let's see if vec0 is still available for us or not. Yeah. Okay, error. This parameter takes ownership. Okay, they have taken the ownership of vec0 here again, and they never really returned it. The vec0 gets consumed inside here. This is very different from other languages. I was reading C, and in C they make copy of the parameter. When a variable is passed to a function, it gets copied, basically calling a clone. But here we are passing that particular value itself. Okay. Um, okay. And we can have a binding that is mutable. This is interesting that here it is declared as immutable and here we are making it mutable. Okay. Move semantics 4. Move 4. What's the error here? On line number 12, first mutable borrow and second mutable borrow. Okay, here they are trying to teach us the concept that there can be only one mutable borrow at a time. To fix the compiler error in the function without adding any new lines. Okay. Without adding any new lines. Without adding any move semantics 4. I'm still looking at third one. Okay. This is I know the solution to this because I have done these exercises before, but here the concept that they're trying to teach is that you cannot have two mutable references to a variable. What you can do here is you can have one at a time. So we create a mutable vec x and we have a mutable reference to it. We push inside it, and after here the y goes out of use. Now we can create another mutable reference z, and this should solve the problem. Okay, I think yeah, now let's see what hint they are trying to give us here. Carefully reason about the range in which each mutable reference is in scope. Does it help to update the value of x immediately after the mutable reference? Read more about mutable references in the book section, references and borrowing. Let's do that. We can fix the code from listing for mutable string. Reference to a mutable string is passed here. Push. This will not work. But the error says that the code is invalid because we cannot borrow s as mutable more than once at a time. Okay, now let's move on to move semantics phi. Move semantics phi. Fix the compiler error without changing anything except adding or removing references, the character ampersand. Okay, shouldn't take ownership. So this function should not take ownership, but it is taking ownership. So let's create, first let's look at the error message. Expected due to the parameter 12, this one. Expected string, found string. Do uppercase, try removing the method call. Should take ownership. So this one should not take ownership. So this one should be ampersand, and this one should take ownership. So let's get cache. Shouldn't take ownership, and here we should pass, instead of passing the variable, we should pass a reference to it, and here we should pass the variable. Okay, now let's look at the hint. I don't want to find the answer. The first problem is that get carries taking ownership of the string, so data is moved, can't be used for string. Yeah. We know what happened now. So move semantics section is done. I would suggest that you go back and do these particular set of exercises again, because these are really key in our understanding of the Rust in the future lessons. Okay, now let's take a short break. How about that? We'll take a 2-minute, 3-minute break here, and I'll be back. Should call it timer. Title text. And break. Short break. short break and let's have a time as well. Okay. I'll be back in 2 minutes. Damn it, all this time my mic was off. Um, Actually, my wife pointed it out that my mic is off during the stream. Hey, if you, are you still there? Coder Finn, are you still there? Can you hear me? Uh, Earlier, I was trying to talk to you about a problem that was in the code, something, but I didn't know that I was muted. Damn it. Thank you, wife, for pointing it out. Uh, GB, I think I can do this. Man, I feel so embarrassed. Uh, and here I can do something like move position, and I can do pass. I can pass a point, and in the point XY, right? In the point XY, I can do X as I can pass this self. Oh yeah, this needs to be self. Self message move B. Okay, okay. Message. I think this needs to be like this. Message resize. Okay. So what happened? What to do when there's a resize? There will be width and there will be height. Mm, resize. Mm, there will be. Uh, does resize also take a point? No, it does not. No, it doesn't. Resize has to be width, weight, and height. Wait. All this time I was muted. Damn it. Can you hear me now? Am I audible? Am I? Am I? Coder, then I cannot add you. Okay, no worries. I think I, this needs to be like this. This needs to be like this. Expected one of the 7 possible tokens. Resize. What am I doing wrong here then? I think I think it was correct earlier. This is correct, and then I need to call it here x comma y self dot resize x comma y. Not a tuple struct or tuple variant. Let's look at enum2. Resize was correct here. Enum3 this This needs to be does not have fields. With right. With right. Okay, this needs to be U64. Okay, now, oh, where is it? Where is it? 64, 64. Yep, that does it. Uh, all this time I was talking on mute. Kinda embarrassing. No worries, no problem. Strings 1. So we have reached strings 1. Um, mm, Fix the compiler error without changing the function signature. Okay. Expected string, but they found a str. This is very easy to do. You can either do this. Okay, this should fix it. Or you can also do this. This should also do the trick. Not new, but yeah, found. Yeah, you can also do this. Now let's move on to strings 2. So the problem here, let's look at the comment. Fix the compiler error in the main function without changing this function. Without changing this function. Okay, so it takes a str, but we are passing it a string. Don't change this line. So I think if we give it a reference, this should fix it. Yep. Now let's move on to string 3. Strings 3. Remove white spaces from both ends of a string. There is something called trim start matches and trim end matches. So white space. Let's look at how the function. Okay. They want us to trim, but they don't want us to remove this space, right? The one that is inside. Let's look at Rust docs. Rust docs string. Trim. Returns the string slice with leading and trailing white spaces removed. Okay, we can just do input dot trim, and in case of this, add world to the string. There are multiple ways to do it. I think one of the ways to do it is push, right? Input dot push str world. Not found. Method not found. What about this? String expected string push str. Dot string cannot be formatted to string. Replace. Let's look if there is a replace. Fn replace. Replaces all the methods of a pattern with another string. Okay, this is what we want. Replace. Replace. Replace cars with the string balloons. Input dot replace cars with balloons. Mm, we are failing on this test. This is not working. Push. STL add assembly. This assembly. Rust STL. Rust docs STL. Push. But this happens on on stream, not on str, right? Push contains. Is there any method called append? Okay, I can do this. How's it going? Hey, I think this is one of the first wrestling. Oh, the you mean strings 3? Hey, by the way, welcome to the stream, Commander Thrash 10. Uh, are you still there? All right. No. This is not the first this is not one of the first. I have solved 38 out of 94 challenges so far. And so need any help? No, not yet, not yet. I think I'll start needing help once I cross the 50% mark. Then I'll start needing course correction, a little bit of help. But so far, no. Let me know if I'm doing something really stupid, okay? Because if it's not idiomatic, so I think what I can do here is I can try to add like this. So this is input is str. Uh, Add word to the string, and I can do string plus I can do world. Yeah, this solved it, right? Wow, this is easier than I expected, honestly. I never wrote any advanced Rust. I know basics, I can understand the idea. That's it. I never wrote any advanced Rust. Yeah, I'm also not really that well versed in Rust. So I have only ever done until chapter 6 of the Rust book. And and these topics after the six, I've never read this part, but I've touched them, these topics, but not never really read the book. Like a few days back, I did this challenge on in Rust. I did this thing: build your own HTTP server. I did this in Rust, but but my code was very messy. It was not testable. It was not modular. So next time when I try it in Rust, I'll do it again. So my plan is that I'll finish Rust. I'll do a little bit of Rust every day. Um, I think the basics are really simple there. Yeah. So is the theory. It is the practice that can get hard if you were doing what it is made for. Yeah. And parallelly, I'm also trying to learn C. So so in the hopes that I can understand what is the role of these two languages in the current industry, like um, why do they exist and those things, and hopefully build some things with these languages. Okay, now moving on to the next challenge, string 4. uh, String 4. um, what is going on here? Calls of this function should be replaced with calls of string slice or string. All right, so they want us to replace, here are a bunch of values, some are string and some are ampersand str. Your task is to replace placeholder with either string slice or string depending on what you think each value is. So this is string slice. String slice back y. This is definitely string, and this is string as well. I think this is string. Um, this yeah. Can you teach me or what do you understand by this? But you have this thick Indian accent. Yeah, yeah. I know. I have a thick Indian accent. And it honestly it makes me kind of conscious about it. Uh, it I was look a few days back. I was looking for a software where I could you know those uh, I think that's what it's called, VTuber VTuber softwares where they convert you into a avatar or anime profiles. Yeah, and they can, and there's something similar for morphing your voice into somebody else's. I think there are softwares for those things. Um, so I was thinking maybe I should do that, and then I wouldn't have to, uh, s- uh, come on screen or use my own voice. Yeah, but we'll talk about that later. So I think two owned. Let's just look about Rust two on. What does two on do? One thing I know that this it does is it takes the ownership of the variable, but does it convert the string into and another thing I feel that it does is it creates a cloned copy. Correct me if I'm wrong. Does do own creates a cloned copy of something, and it clones into like creates separate clone for you. We don't have to creates our own data from borrowable data usually by clone. Yeah, exactly. So yeah, so it converts a str into a string. So this is going to be a string, and and into is something that I'm really not sure what it does. So let's look at that. Rustdocs into. The point is that like it's only really just ban anyone who says what it is. Yeah, can you explain to me what? But damn, not in chat. I do have a Discord, uh, but I'm not really active there. So let's do voice call. I'll explain. Okay, give me 1 second. I think in let me try to paraphrase this. And correct me if I'm wrong. Correct me if I'm understanding it incorrectly. It converts it it converts one type into the another. Like other these other languages have what is it called? Morphing, morphing one type into another. Is that uh, technically speaking? Yeah, casting. Yeah, casting. Uh, but that's not the point. Okay. Uh, what does a value to value conversion that consumes input value and the opposite of from. So when we do string from and we convert a str into a string, and this into is the reversed, the opposite. So I'm guessing this returns a str. One should avoid implementing into and implement from instead implementing it from. You know what? Let's command it trash them. Okay, give me a second. I'll send you a request on. I'll send you a request on Discord. Discord. Uh, Command trash them. That's not what it's important about. All right, explain. Um, Add friend. Send friend request. All right, sent you a friend request on Discord. Um, hey. Oh, you are also in the Rust server. Okay, that's
that they're really not even like in the same, like technically they can also, like, you can have like a, anyway, for
mhm. uh yeah. So I recently finished this chapter on pointers. Um yeah. Mhm. Mm-hmm.
the heap
Mm-hmm.
where this is, this array begins. And then you basically, like, if you want to, you can allocate as some space for it, a continuous space. And
Mm-hmm.
this is where it will be, like, you can add stuff in there, but you need to keep track of how, like, where's the last element that you put in there, and so on. And then in the end of the program, C program, that is, this is a heap allocated memory, so it won't be freed just by itself by like dropping the stack frames, and you will need to delete it manually. You will
Deallocate.
need to free it, right?
Mm-hmm.
So this is really annoying, and it really messes up a lot of things, especially if you create it in one place, then return it, then somebody else does something with it, and then you immediately you lose track of it quickly, which is the big problem with C. So this is why people came up with this, like, more or less automatic, semi-automatic system for handling memory, which is both in C++ and in Rust, with the exception that in Rust they try to make it explicit by annotating it in the type system and more automatic that way. And the system is basically what you want to have is a container of a fixed size, of a known size, that inside of that container is a pointer to this heap memory that is like your string or array, whatever.
Mm-hmm.
And this container does all the work, for you. So if you know the data, do you know the data structures, different data structures,
Yeah.
like vectors, hash maps,
Yeah.
red black tree maps,
Yeah.
or like, well, ordered maps, all of that shit, linked lists. So
Yeah.
they always consist of two parts. One part is like the actual sort of structure representation as
Mm-hmm.
it is. So if it's a vector, it's the array inside. This is like the continuous, like, piece of memory. If it's a list, then, well, it's the first node inside, which then points to the next node, and so
Mm-hmm.
on. And, well, for trees, it's like the pointer to tree, or, well, or something to the root of the tree. And you
Yeah.
get the idea.
Yeah.
And then the second part is the wrapper, like wrapper structure that contains this whole thing. And this structure does all the important work for you. So whenever you want to push an element into the vector, you don't really need to, like, think too much. You just say push, or push back, I guess,
Yeah.
depending on the language, right? And then it does what it does. It tracks the last element for you. If the last element is at the size, or, like, well, yeah, it's at the size, so the array is full, it needs to allocate a new array that is bigger, then copy all the elements into this new array, then free the previous array, and then
Okay.
push your element back, and so on. And that's the same for everything else, for hash maps, for linked lists. They all do these, like, little transformations in there inside, but you only call the methods. You don't care about any of that
Hmm.
shit. This is what ownership is. This is basically you saying, well, okay, so there is this, like, inner structure that it has, like, the structure, but the operations are still non-trivial. And so I will have this wrapper structure that will trivialize the operation for me as the user, basically create a nice, simple interface, right? And then I will just call to that interface, and whatever happens inside is up to the implementation. And this is what to owned is. It says,
Okay.
okay, so here is the inner structure we're giving you. Can it, like, does it even make sense to say that there can be a wrapper structure around it that manages it in some way, right? If it can, then to owned creates this wrapper and returns it to you. So in that case, since Rust
Uh.
parses these, like, literal strings as these str, basically like a C kind of array, kind of,
Yeah.
right? Then, what they say is, like, surely you don't want to use these and instead want to use string, which is the wrapper. Then you can call to owned on this literal string and get an actual, like,
Wait. Wait. Wait.
capital S string.
wait. So I'll try to rephrase what I understood from your what you just said,
Yeah, sure, yeah.
and correct me if I'm wrong. So so when I on a string, when I call to owned on a variable, uh, underneath it, it creates a clone into the heap memory, uh, and it gives me the ownership of that, right? So
Well, it doesn't have to create a clone. Like, I,
okay,
I
can you
mean, okay, so
wait, can you
I'm
see
not
my
actually
screen?
sure.
Can you?
Yeah, yeah.
I'll type something and tell me what is the difference between the two. Let's say that x is equals to string from.
Man, what is n? Oh, and it's Vim. Okay, yeah,
Oh yeah, it's just a shortcut to alias. I have aliased it to
yeah.
ct this. Let y is equals to x dot clone. Uh, mm, let z is equals to. Tell me what is the difference between these two operations going on here.
You mean the to own one and the from one or something?
To owned and
Oh,
making a clone of the x. Can I still access x here? Yeah, so I still have x at my disposal despite being to. So I'm not sure what is going on here and why should I use this and when I can any make a clone anytime, right?
well, actually, this is interesting because are you sure that compiles? Like, well, let me check
Uh,
again. You sure
uh,
that compiles? X.
yep,
Yeah.
it does.
Uh, hmm. Because, like, my understanding is that X here is a string with a capital S, right?
Yeah, yeah.
So it is already, you already own it.
Yeah, so X owns the data that is hello,
Yeah,
and,
exactly.
and Y is just a clone of it. So what is happening here is that here in the memory there are two hellos, okay, two separate, entirely
Yeah, no, I
separate.
mean, so first you clone it, that's fine, but then the
Yeah.
X itself is untouched. So what happens if you remove the Y? Does it even change anything?
So
Like
what?
if you remove this whole line like completely.
Yeah, this doesn't affect anything. So that doesn't affect
Okay, yeah.
anything.
I didn't know that you can like call to owned on a string. I thought that you could only call it on str.
No, uh, you can do that here. So this is in the this is in the heap, right? And what is happening when I do this? What is happening when I do a to owned on X? What is going underneath here? So when I look at Rust docs to owned.
Actually, let me also check something because this is, I mean, hey, what if you end up teaching me something?
So they
Okay, well,
say
one
that
second.
to own creates own data from borrowed data, usually by cloning. Okay.
Yeah, but like I didn't think that X was borrowed. This is what surprises me. One sec. Um, so let me just do it in the Godbolt so I know. Thing from hello, right? And then we do let X to something.
There is a
Um,
string.
uh,
Yeah, so I'm looking at the docs of string, and it says creates own data from borrowed data, usually by cloning.
yeah,
So
yeah, yeah, exactly. So this is why I.
so underneath the to owned, it is making another copy of hello, right? Um,
Well, in that case, I would say yes
and
because
and
you
giving me
already
the
own the X.
ownership of the new clone that it made. So
Well, yes.
so technically, at least in these two lines, they are identical operations are happening underneath, right?
Well, yeah, but I mean that's what it says in the docs as well. So this is a generalization of clone to
Yeah.
borrow data.
So what
Uh,
happens when I do? Tell me what happens here. What is going on here? It says error.
to into
Yeah.
what?
No, 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 not two into, but this type annotations. I think this is a general casting.
Well, yeah, but like then you need to.
I think I cannot move back. What
Yeah,
do you?
you can. I
Okay,
think you can extract
yeah.
it from it.
Check the error. The X has moved. I cannot access X here anymore.
Yeah, yeah, but that's because of the previous line,
Oh,
probably.
no,
Actually,
no, no,
wait,
no,
let
no.
me
Wait,
check.
wait, wait. Not because of previous line, but because of this. Because I'm accessing X here. So what into does, this is just my speculation, okay? I'm
Oh,
just
yeah, okay.
So what into does is it's giving the ownership. It is converting it is converting it into a string. It is already string, but it is converting into string, but giving the ownership of X to A. So let me run this for you, and you will see the error messages. Uh, Check this. Yeah, move occurs. Um, yeah, the X is moved due to this call, due to into, and therefore I cannot access X anymore. X. So this is new to me as well. X is moved here.
Oh, I think I know why. Yeah. Okay, I get it. Sorry. So, okay, I think I
Y-
can explain what happens.
Yeah.
Uh, it's just okay. So, man, this I don't know. Like, this is why I'm not a big fan of Rust because sometimes I don't really get their design.
Mhm.
But whatever. So they kind of merged two things here in this two owned, which I thought it's only like one, but they really insist on like doing two things. Well, they really insist on doing one of two things for whatever reason. So basically, they clone when it's already owned, but when it's not owned, that is, if it's a thing that only makes sense to use in a container, the way I described to you, then they wrap it and then give you the like the clone thing basically. So it's like you can consider this to own to be
Oh,
like a good clone that you will always get the data that is not like dangling
s-
anywhere or something.
yeah. So it says usually, so there could be other ways of
Yeah, for
doing.
example, and this is what I think happens in your code. For
Mhm.
example, if you have a literal string somewhere in your code, like you literally go like quote, hello quote, right? Then when you call to owned on it immediately, they don't really need to create a static, string and then clone it for you and all of that because you won't be able ever to access that initial string that is literal string. You will not use it, so they don't need to clone anything. They can just give it to you wrapped as it is. They can create like you know a proper capital S string in place. Cloning is only necessary if you actually can still access like the previous object as well. Then yeah, then you'd
Okay.
need cloning. But if you
Uh-huh.
cannot, then they can optimize it, right? Because
Okay. There could be
you will never
situations.
be able to. Yeah, yeah, yeah.
So you're saying that and there are many situations where I don't have access to X anymore, so I cannot run a cloned here because the value might have moved.
Yeah,
But
but
but but there I
with
can
any
but there I
with
can
any in
do
place call, for example.
but there I can do two owned, you're saying? For example, just let's look at this. We already know that X has moved, right? Now let's try to see if we can do two owned on it. X two. No, we cannot do two owned here because the value is moved. So once
Yeah,
the value is moved, we don't have the access to X anymore.
yeah.
Mm-hmm.
That is, this is again, this is the move semantics is a cool quirk of Rust because I thought about it a lot. And first I thought like, okay, so moving, like doing a reference or move semantics is pretty stupid. Isn't it better, like more natural to do it the way they do it in C++, where it's
What is the
reference
way?
or value?
What?
Reference or value. So the way they do it in C++ is you can pass by reference or you can pass by value, which basically copies the thing.
Yeah, you
But
can
then I
do.
was like,
You can
yeah,
do
yeah, no,
that.
sure, you can do that by cloning.
No, no, no. You can do things like passing a reference like this.
No, yeah. So you can pass a reference, but you cannot pass a quote unquote value because it doesn't automatically clone anything. But then I
Ha
started
ha
thinking
ha ha.
about it. I'm like, actually, you know what? It is almost always better to move if you want this.
Yeah.
But if you want like a copy, then well,
So
type an explicit copy. So
so I was
yeah, it's a cool thing.
so I was learning C, and in the C, they said that in any function, when you pass a value to a function, it creates a copy of the parameters, right?
Well, yes.
Yeah, but not in Rust, if I'm not wrong.
Yeah, yeah, that's what I'm saying.
Yeah.
Well, C is not as illustrative of this because it doesn't really have a lot of like big values. They are very honest about what they're doing. They only give you primitives and pointers.
Yeah.
So yeah, but in C++ you do pass things around. You can pass a
Hmm.
vector around or a structure, and if you write it without a reference, like you have a vector with like a billion numbers and you pass it without a reference, what it will do immediately is copy the whole thing and pass in a copy like under the hood, which is maybe not what you want.
All
So
right.
yeah, so and that was the thing. And in C++ you'd have to manually write std move to move
Oh,
things.
C++ also has something like move, you're saying?
Well, I mean, of course, for any manually memory managed language, you want to be able to move. Otherwise, any code becomes like a hell. You can't write that. Like you need to be able to move, or you will actually be slower than any garbage collected garbage.
To owned and into, and I'll also I think so. The next chapter that I'm doing in my book that I'm reading on C, it talks about arrays. So I think there
Talks
are
about what?
arrays.
Oh, array. Yeah. Well,
So I think
yeah.
this is where I'll actually learn the
Oh,
power,
yeah, yeah. Well, you'll see. You'll see. Yeah.
the point. Yeah.
You. Uh, okay. I'm not. Yeah. I'm not really. Like, I don't really know that much C. I mean, I know it enough to write it, but I wrote C++ mostly. So
Hmm.
yeah, I cannot really give you an example, but like it is important to maybe implement your own kind of vector in
Okay.
Rust.
All right.
Like
You think that will
then you
teach
will
me?
understand. Oh yeah, yeah. This will
Okay.
explain to you why is the concept of ownership important and what it
Hmm.
does. You try using an array in C first, see how that works out for you, see that there are no memory leaks and such. Then you try to implement your own in C++ or Rust and
Hmm.
see how that makes it like 100 times better, basically.
All right. I'll try doing that. Maybe hopefully sometime in stream itself.
Yeah, I
Uh,
mean, sure. Also, feel free to ask me stuff. I'm just sometimes looking through the software and the development to each
did
part, and
you
then I'm like
did you
helping random people.
yeah, did you sort by viewership on low to high? Did you do that?
No, I usually sort it from high to low, and then but like it doesn't matter. I just go to a stream where somebody's learning or somebody's doing
Mm.
something that I care about. Like the problem with streams with a lot of people is that you cannot actually talk to anybody there.
Yeah.
Like no, I mean, it makes sense, right? If you have like 100 people on your stream,
Yeah,
obviously you won't be able to talk.
you cannot give
Yeah, you
equal
cannot.
time to everyone, right?
Yeah, yeah, yeah. I mean, and then because you cannot give it to everyone,
Hmm.
you cannot give it to anyone. Otherwise, it will be kind
Hmm.
of unfair or something. So I don't usually, go to those. And then a lot of
Yeah.
people are doing something very specific, like, oh, I'm making a game or something. But well, I don't care about that. And so it leaves out basically people like I don't know people who are learning like you, or people who are doing some weird shit, this I can get behind. I also stream myself, or at least I did.
or you
I was using
no,
Emacs
no,
because
not
that's
now. What do you use now?
just VS Code.
Yeah,
Because I can't be bothered. Like the
yeah, yeah.
VS
No,
Code
no,
is
I
just like,
totally get it. Look, if you noticed that I'm not using any code completion or any fancy stuff,
yeah,
because I wanted to force myself to do all the writing. I didn't want to be handheld. Uh, but yeah, but yeah, most of my professional work that I do happens on IntelliJ.
yeah. No, it's just that Emacs is kind of cool, and I absolutely, I don't mind, like, using it. It's
Yeah,
just that it breaks sometimes, and it's like complicated, and VS Code is just like,
I
it's
know.
the experience I'm looking for. I was using Emacs for 6 years. I think I'm a good judge of, like, with VS Code, I just open it and I press a button,
Yeah, yeah.
give me this, and I get the thing. With Emacs, it's like a lot of work.
Well, yeah, I think you should stream. I've given you a follow, and
Yeah,
hopefully you should
man.
stream.
Like, yeah,
I mean, because
absolutely. I
because
was just
you
procrastinating lately. That's it.
uh, and maybe you should stream on YouTube at the same time. And so there's this service called Restream. Uh, Restream.
Yeah, I know. But see, the problem is usually nobody shows up, which
Yeah. If you
discourages me a lot because I
it
want to,
it's
like, the whole point is to talk to people, right? If nobody
yeah.
shows up, that only
Uh,
reinforces the fact that I'm nobody. And I'm doing weird shit. I'm doing like compiler exploration and language building and
and this
so
is this
on.
is why saying that you should stream on YouTube. Because why? Why? Because YouTube keeps an archive of every stream. So if someone like maybe years down the line comes across a problem that you have solved, they can look at your stream and go through stuff.
Well, I mean, yeah, maybe. Yeah, I mean,
So
yeah.
this is a string as well. Format. This is also a string.
Let me actually check. Placeholder format.
Yeah,
Yeah,
format returns a string, and this is a slice string because it is like evident here itself. It's a
yeah. It says that this is a
and this is a
slice.
slice as well. So and
Yeah, I'm pretty sure that.
trim also returns a slice, I think.
Yeah, I would imagine it does, like,
Uh,
it leaves the type the same or something. I don't know if you can trim a capital S string.
you can. Wait, I'll show you.
Yeah.
Where is yeah? This is string, right? Trim.
Yeah, I mean, this is really just about, like, types
Yeah, but
of
it returns
these functions.
even if you like trim a string, it will return a str.
Uh,
So I think same goes for
that's
replace.
actually kind of weird. Like, why?
Yeah, yeah, I don't understand why, because you're giving it a string and then uh, it returns a str. Let's test this. Let's see how many we get right. Um, Strings we got a few wrong. So the replace has to be string. Replace has to be string. Lowercase has to be string. So these two I got wrong.
Okay. Oh, to lowercase is actually to lowercase is interesting. Wait, let me check something.
Yeah.
I had a bad memory about this to lowercase thing.
So these two are strings. These two are I got wrong, but rest I got correct. So let me look at the lowercase. Replace. Replace.
Oh yeah, no, for string it's like, okay. It's for characters that it does the weird shit. Oh man.
Remove. I think I can move on to the next one. Modules. I think I'll stop here for today.
Yeah, that's all right.
It's 1 hours and 36 minutes. All right, so that was really fun talking to you. Uh, what is this? Cheap viewers? No, I don't want cheap viewers. Can I ban this person? I think I can ban them. Yeah. Okay. All right. So if anyone is there, give Commander a follow. How to give a shout out? Can I give a shout out? Commander Thrash Den. I should just copy their name from here. Yeah, go give this person a follow and you can talk to them. They'll help out as well. Yeah, our so I'm gonna stop streaming for now. Our next chapters are modules, hash maps, and quiz 2. Remember, I did quiz 1 and options. I've used options, errors, and all of this before, but yeah, traits. Traits is something that I really am not that familiar with, and generics. These so I have done rustlings before, and then I have only done until errors. And from here onwards, from generic onwards, everything is uncharted water. This will be interesting. Lifetimes will be interesting. Okay, so hopefully I'll see you the next time, and I hope you have a great rest of the day. Bye.